Okay, so what distance above the Earth is the acceleration halved? So we want to know the acceleration or the distance when the acceleration is half of what is at the surface. And it is 9.81 at the surface. So the acceleration we want is this divided by 2. Cool. That is our acceleration. But how do you find acceleration? Do we have a formula? Well, we actually do. We have the force formula. Force is equal to, well, the gravitational constant g times the mass of the object times the mass of the Earth divided by the distance squared. But since this force is the only thing that's acting on this object, we can denote it as the net force. And the net force is equal to, by Newton's second law, mass times acceleration. Great. Now we can, with this formula over here, we can simply cancel out the mass of the object from both sides. We have the acceleration here, our desired acceleration, and we do have the mass of the Earth. The mass of the Earth is just simply 5.972 times 10 to the power of 24 kilograms. Okay, let's redraw the E. And we also have the distance, r. Well, the radius of the Earth is r. X we can call the distance that we want, the distance above the surface where the acceleration is halved. So r over here, right here, that's being squared is actually the radius of the Earth plus x. This is the radius of the Earth, because this is Earth, and Earth is round. So the radius of the Earth is, if you look it up, 78 kilometers. So if we want to change that to meters, we just simply multiply 10 to the power of 3 meters. Okay, now that we have our constants down, which g, our gravitational constant, is 6.67 times 10 to the power of negative 11. It's a very small number. Now we can rearrange this formula up here, right here, this formula, into a formula that we can use to solve for r, which is actually the radius of the Earth plus x. So to simply rewrite the formula, we have the constant g times the mass divided by our desired acceleration is equal to, well, if we substitute this formula right here into our r, we can get r, radius of the Earth, plus x squared. Okay, so gm over a we can find because we have defined our variables, our constants. X right here is what we want. This is what we want. So to get rid of the squared, we would have to take the square root of both sides. Oops. The square root of both sides. That will cancel out the 2. Now we want to isolate the x. So we subtract the radius of the Earth from both sides. And that will result with just our x. To simply rewrite this formula up here, right here, we will get x is equal to, remember x is what we want, is equal to the square root of the constant g times the mass divided by our desired acceleration minus the radius of the Earth. And since we have our constants over here, from here all the way down to here, we can just plug these numbers in and do the simple algebra, and Rx will end up being 2.6 times 10 to the 6 meters. Or if you want it in kilometers, you can simply convert it into 2,600 kilometers. That is our answer. Thank you.